Welcome, everyone. Thank you for coming to this seminar. So our speaker today is Nick Brown. He is the PermafrostNet's data scientist. So Nick completed a bachelor degree in environmental geoscience with a minor in mathematics. He also did his master in geography with a specialization in data science. So Nick is here today to talk to us about Permafrost data, the challenges, opportunities, and next practices. There will be a period for questions at the end, so please feel free to either write them in the chat or just unmute yourselves after the presentation to ask a question. All right, Nick, up to you.
Okay, thanks. I'll share my screen. So as Charles said, the talk is challenges, opportunities, and next practices in permafrost data, and I'll really be kind of talking a little bit about how the network is, or recommendations within the network, and how I think we ought to be handling data interoperability. So how do we get all of the different data sets to work together? And then that extends also to other organizations that host permafrost data, because as you'll see, there's quite a landscape of different permafrost data holders. I'd like to acknowledge Compute Canada. They, through a research platforms and portals grant, provide a lot of the compute infrastructure that all of the PermafrostNet things run on. So just getting that in there. Hello. Okay. So some of the themes in the next half hour or so, I'll introduce kind of an overview of data interoperability and metadata, and what the permafrost landscape is, going back to a data workshop that we held in 2020. Some of you may have been there. Then talk a little bit about data and metadata interoperability for PermafrostNet, how we're handling that and what our recommendations are, and what kind of next practices could be for interoperability for permafrost data. And then finally talk a little bit about some new and some improved tools to support network research that I've been working on. And that's a little bit different, but those are things that are now starting to get used in the various themes to support the projects. So by the end of the talk, I hope that you'll know a little bit more about kind of the current data management best practices and how they can be applied to permafrost data within the network here, and also maybe if you're not within PermafrostNet in your organization. So I think by now everyone's familiar with open data, and since 2016 there's this idea of FAIR data. So FAIR is an acronym that stands for findable, accessible, interoperable, and reusable. This was a paper that was put out. There's a website, gofair.org, that has very specific criteria for each of these different categories. And I've described a few of them here. So findable means that if I'm a researcher and I'm looking for data about permafrost, I can find it. I don't have to ask someone, on the street or call up someone and say, hey, like where can I get this? It's described with rich metadata. It has a globally unique and persistent identifier that's like a DOI that you might see on a paper. And if I type it into some sort of data set search or some sort of data aggregator, it'll come up. The next one is accessible. So once I say, okay, well, here's this resource, you can get it. It's available on some kind of transport protocol. So the internet, for instance, that's open, free, and universally implementable. And it also means that the metadata continue to be accessible even when the data might be no longer available or restricted for some reason. And quite a lot of permafrost data and data in general meets these first two categories, findable, accessible. And where things start to get a little more challenging is in the next two criteria, interoperable. So that means that data from different systems or different organizations can be used together in a reasonably easy way. So this includes that the metadata and data use vocabularies that themselves follow the FAIR principles. And I'll talk a little bit more about that later. It also, there's also this emphasis on both human and machine readability. So not only can a person go to these two data sources and say, oh, well, this is a data set that has temperature, but I know it's ground temperature, and this one says it's ground temperature, and I know that those are kind of the same. The machine readability piece emphasizes how can we represent that in a way that if you're searching for ground temperature, for instance, that those two variables are really identified as being the same thing and being able to be used together. And then the last criteria is reusable. So this has the idea of domain relevant community standards, and some of these have been developed already. Certainly the Northwest Territories and Yukon geological surveys have metadata templates and data templates for data within their databases. I think we're kind of starting to get these domain relevant community standards established in kind of a introductory way, and I think some of the next practice will be how to harmonize those and represent them in a way so that they're interoperable and they meet these FAIR standards. And then lastly, another criteria here is that the data or metadata are richly described with a plurality of accurate and relevant attributes. And here again, there's a lot of if you look in the old reports, there's a lot of attributes that are maybe accurate, but maybe less relevant to permafrost research. So if you're looking at a geotechnical borehole, it's certainly maybe relevant, who the driller was or what kind of drill fluid they used, but it might not be relevant to the kind of research that we're doing now. And then also accuracy, and that's obviously desirable in any case, but it's part of this idea of reusability. If I'm a researcher or if I'm anyone who wants to go to a database and reuse something, if I'm skeptical that the data or the metadata is accurate, it makes it a lot harder to justify reusing that data. So these are the FAIR data principles. And if you look at a Google Trends search, the paper that described these came out in 2016, and the kind of interest over time is steadily rising. And so this is something that's becoming increasingly important, especially as we start to get more data sets available online, but not always conforming to this idea of FAIR. So I'll take you back now to 2020 to the Permafrost Data Workshop. This was intended to be an in-person workshop, but ended up being online. And it was near the beginning of PermafrostNet and was designed to bring people together to talk about some of these issues because of the sort of central role that data plays in PermafrostNet, being generated, for instance, in theme 1 and then reused in some of the modeling activities in theme 3. It was kind of some of the ideas in the proposal. And just at a high level, some of the themes that emerged from that is that we really need capacity building at all levels. At the data management, data holding institutions, there's a need for more resources to do the data rescue, data management and publication. And then at the data creator level, the people who are going out and collecting that, there's a need for guidance, for shared tools, for, again, more resources. So this is kind of an area where something's needed, and this is something that's kind of come up if you look at previous permafrost reports. This kind of need for capacity building, and also at another workshop that's happened more recently, I'll discuss in a sec. Another theme that came up and something that comes up a lot in these kinds of things is that we should be using existing tools and solutions to conserve the resources that we have. So don't duplicate effort, and make sure these things can last in the long term. Access to the standardized data and discoverability by, that should say, researchers, I guess, or people who are looking for it, remains a challenge. I think since this workshop has happened, the availability of data on the territorial and federal databases has increased by quite a lot. So it'd be interesting to see if that's changed. But certainly at the time, people felt like they really couldn't get that standardized data easily. And the last kind of main theme is that we need this continued communication between the different nodes in the Permafrost data system so that we can make sure that things aren't developed in isolation. Participants were asked at the workshop to imagine a Permafrost data system in 10 years from different perspectives. So the perspective of someone accessing data, producing or submitting it, and then at the final step, someone who's managing or distributing it. And I invite you to, after the talk or late another day, I have the DOI here for the report, so this is just a sampling, but some of the things that came up for accessing, having standards and methods to mesh data sets from different sources. So this is really getting to these FAIR principles that I was talking about, having multiple ways to access it. So this is, I think, something that's quite important and something that I've been trying to kind of think through. Someone who's running simulations and writing programs will want to access the data a different way than someone who's maybe looking at a very specific site. So it's the difference between writing some code to just scrape data off a database or off a server and aggregate it versus having, you know, a nice user interface on the internet where you can, it's very interactive and you can discover things in a more serendipitous way, maybe things that are near your research site or related somehow. The vision for people submitting or generating the data is having these metadata templates with defined vocabularies that are very clear and very well documented. And again, having tools and things to support them with the data management. And then at the management level, this idea came up of decentralized permafrost data. And this is certainly what we have right now. And I think it's hard to avoid having some level of decentralization, but with strong coordination between the nodes and with the international community, and having some kind of regional structure that feeds into national or international communities. So you might have data management capacity or organizations in the territories and in the federal government and maybe in the university, and having some sort of communication and coordination between them. At the regional conference on permafrost in 2021, we had another workshop and talked through kind of some of the challenges and recommendations that people had. It was a fairly short session, but again, some of the similar kinds of things came up. You know, the resources, capacity, and services needed for permafrost data management mostly do not exist at present, but are needed. There are no real international standards for permafrost data. The recommendations that came out that should make it readable by humans and by computers, again, getting back to the FAIR principles, and traceable to the original state. Understand and meet the needs of different user groups. Take small steps to balance the needs for fast progress and high quality. There's this, I guess, challenge of wanting to get things out and published quickly, but also wanting to make sure that the accuracy is there. So there's a sort of a trade-off. We want to make sure that things are good enough without, you know, wanting them to be perfect to slow things down, but we also want to make sure they're accurate and they're not going to reduce that trust and credibility in the data sets. So then the next point, a permafrost data management ecosystem should simplify data standardization so that contributions can be recognized and cited and allow for different kinds of data. And then finally, there was a point that I'll include here is that, and this relates to this idea of using services that exist already, is look at generic standardization advice from data librarians or other organizations that do this already. And so from that, I'll kind of lay out the strategy that I'm using for data within PermafrostNet. So from the proposal, the description of my role in general is prototype reliable and useful, or I guess this is the network in general, but prototype reliable and useful data and knowledge products, and then produce a set of interoperable permafrost databases that can be jointly interrogated. And one thing I think, keeping in mind the previous points that were made, is that PermafrostNet's not a data repository. We're not something that's going to exist long term. So the focus, I think, needs to be on prototyping how these things can be distributed in a way that can be maybe adopted by other organizations, and rely on existing long-term data archives or data repositories to actually keep the data. So within people who are generating data sets in the network, making sure that those end up somewhere like Nordic NAD or a data publication, and then focusing on how can we, while the network exists, prototype these ways of distributing them in a way that meet all of those criteria, different ways to access, standardized, interoperable. Then don't reinvent the wheel. This is something that came up in a lot of these workshops. So adopt existing standards, adopt existing tools, and adapt them for what we need. And then finally, build tools that can be reused rather than things that are hyper-specific to certain projects. So in Canada, we see that there's a lot of work being put towards different permafrost databases. So the Yukon Geological Survey, Northwest Territories Geological Survey, and the Canadian Geological Survey through the PIN, or Permafrost Information Network, have been compiling and publishing a number of different kinds of data. So at the YGS, there's ground temperature reports, geotechnical data. Similarly, NTGS, ground temperature and geotechnical data, and PIN is currently geotechnical data. I believe that will expand to be ground temperature as well. And then internationally, we see other kinds of data. And at GTNP, for instance, there's talk about adding ERT geophysics as one of the kinds of data that they're distributing. So permafrost data is kind of, there's these very specific things like ground temperature and soil profile, but then if we expand that out, there are other kinds of data that we need to consider being able to represent and to integrate. And so the question is, how can all of these different services be integrated? Some of them have similar metadata, but not exactly the same. So some human intervention is required to combine them. But for someone who's running large sets of simulations across Canada, for instance, and wants to parameterize the models using all available data, or validate those models against as much available ground temperature data as they can, it would be valuable to have some kind of way to pull the latest data or to compile it all at once, and then update that and refine things as new data was being added, because these things are constantly being updated, and it's challenging, as I said, to be able to pull them all together. So one of the tools that I've adopted for the network as a way to distribute the data is this tool called ERDAP, and it's a data server that acts as a middleman between the data sources and different users, and it's widely used in the oceanographic and meteorological communities. It has a number of advantages that really fit some of the criteria. So it produces machine readable metadata from the data sets. It's compatible with several existing standards that can be discovered or harvested by other aggregators like the Google dataset search, for instance. It makes permafrost data more accessible to other earth science disciplines, people who are maybe not so familiar with the domains, the domain specific actors, but kind of just need a general all-purpose interface. And because it has this standard interface, we can take advantage of existing visualization tools that are built on top of this platform. And it's something that can be adopted by other organizations in the future, or kind of built collaboratively. And when I say other things can be built on top, as an example, the ocean science community has this ocean explorer that's built on top of ERDAP servers, and you can see it kind of shows you all of the different data sets that are hosted on there, and then gives you links to the landing page for those data sets where you can download them. And this is, again, something that I think if the ERDAP interface were implemented by PermafrostNet or others in the permafrost community, rather than having to build all of these search and data visualization interfaces from scratch, we could start to take advantage of all other already built solutions. Another example is the MODAT, the Merged Observatory Data for Arctic Air Temperature. This is a project out of Seine-Laval. And similarly, each of these meteorological stations is an ERDAP data set that's hosted at Seine-Laval. And this is just a interface that's been built off of it. And then you can see here the various metadata attributes. So thinking about how permafrost data are used and what kinds of standards we might want to adopt, we should think about what are some of the aims, how is this data being used? So in PermafrostNet, I think some of the context is to help understand and mitigate permafrost hazards under climate change. So there's this sort of intersection of three domains. There's the climate atmosphere, the climate event or trend, combined with some interaction with the terrestrial environment, and then coinciding with infrastructure and land use. And so on the left, the climate event or trend, there's a lot of overlap with the atmospheric climate science community. On the right, the terrestrial environment, there's a lot of overlap with the geological sciences, and this is superficial geology, quaternary geology, geomorphology, and geotechnical engineering. So looking to these communities to adopt standards and best practices for data means that all of a sudden we can share data with these communities more efficiently. And the data, permafrost data itself is often a kind of a combination of these things. So atmosphere deals a lot with time series and model outputs, which we obviously have in permafrost data as well. And then in the geological sphere, we have boreholes or static maps. So when we think about the data standardization, it's important, I think, to consider these two communities and how what we can adopt from there. And one of the one of the resources that exists already more in the atmospheric community is the CF standard names. So it's a list or a vocabulary of variable names that can be used as a data attribute. So it's really a label that you might put on if you have your data set here with your from, to, some variables. Each variable might have a set of attributes. So what are the units? What's the description? What's the accuracy, precision? And then what's the standard name? And that can be used to search for the same kind of data. And it provides an unambiguous external reference so that if I'm looking at two data sets from two different providers, and they both use this same label, which might be, in this case, visible ice, but could also be ground temperature or excess ice content, to have a more permafrost specific example, I can be increasingly confident that these actually represent the same thing and that I can combine them easily. And in collaboration with Michel Paquette, who was a postdoc in Theme 1, we adapted in a way this standard names table. So we've put in 2 sets of requests to add permafrost relevant terms to this vocabulary, because, as I said, it's sort of originated in the oceanographic, meteorological, and climate data, but it was missing a lot of terms that are relevant for the kind of work that's being done in PermafrostNet for observational and terrestrial variables. So some examples, things like thaw depth, slope, Atterberg plastic limits, silt content by weights. These are data that either exist in permafrost databases or being collected. And so just to go back, this now becomes a resource that can be used within the network to add these attributes to data sets. And it makes it more easy to interoperate or to share data with other scientists or other researchers. And it uses this existing framework rather than trying to come up with it entirely ourselves. So for thinking about metadata and metadata recommendations for within PermafrostNet, some of the goals were have this adopt and adapt approach, focus on robust attribution. A lot of I think the concerns about sharing data, and certainly some concerns that came up in some of these workshops, is really wanting to recognize who created the data set, who did kind of the editing work, who might have digitized it. And in journal articles, we see there's a taxonomy for assigning different roles to say, well, this person, they came up with the idea, and this person maybe did some of the writing and literature review. And so how can we adopt something that allows us for data sets to have this really good attribution? And then, of course, we want something that's compatible with existing permafrost data templates, because, as I said, the Northwest Territories and Yukon geological surveys have developed these data templates. So there are 2 kind of metadata frameworks that fit within the CF and ERDAP ecosystem. There's the attribute convention for data discovery, and then certain metadata attributes from the ocean science community that really get into this attribution piece. So for a data set, you could have references, creator name, what was the institution, links to other metadata. So if we're distributing something that has an original source, being able to provide that and reference back to the original source. And then what are the contributor names or roles? So this is where we can start to describe who collected the data set, who edited it, who's publishing it, and capture that attribution in a rich and robust way. And then compatibility with existing data templates is something that starts to get a little tricky, because they're not always necessarily compatible with one another. So I think this is an opportunity within the permafrost community for increasing this interoperability by harmonizing these different metadata vocabularies. So if we look at the NTGS template for metadata template for ground temperature data sets, there's an entry for disturbance, which is of course something you want to know if you're looking at ground temperature. And similarly in the GTNP, which is the global permafrost temperature database, there's a metadata for thermal disturbance. And what's missing here, there's two things, I think. One is what do each of these actually mean? And some of them are kind of obvious. But without a published definition of what each of these means, it's, I think, difficult for people outside of the permafrost community to contribute data or to combine data. And then the second thing is how does someone go about integrating these if they want to start to combine these data sets and look at, how different disturbances affect an area. And it's certainly, not particularly difficult to make a mapping between these two things. Some of them might be a little bit incompatible, but how do you make those integrations reproducible and traceable? And I think a better way to do this would be to have some sort of mapping that's published that can be agreed upon by the community and reproduced, so that if successive researchers or organizations are using this data together, that the way that these categories are mapped onto one another is done the same way, or at least can be done the same way. And there are some tools and best practices for vocabularies that I'll get into, but I'll just take a brief diversion and talk a little bit about some vocabulary work that I'm doing in collaboration with Teddy Herring in Theme 1 for the Canadian Permafrost ERT database. I can't remember the acronym, but CPERS. And so in that database, there's a list of landforms. So for an ERT survey, you can say it's covering a debris-covered glacier, or it's in a glacier forefield. And part of this is having something that people can contribute to, so it's community built, and it's a shared resource rather than fragmented ones that are developed separately. There's a link here in the bottom. I think probably will make the presentation available afterwards, but starting to collect the vocabulary terms in a GitLab repository, or just an online repository where people can request new terms. They can look at the list and pick from it. And if something's not there, or they want to add something, there's a way to make a request to say, I think this line form should be added, or I think this definition is a bit funny. And it's represented both in machine readable forms and human readable forms using this semantic web technology. I won't get into it in any detail, but it's a way of representing vocabularies in a way that's machine readable and designed for consumption on the internet. There's the CPA action group to revise the permafrost glossary. There is an action group in the CPA to revise the permafrost glossary, which I'm a part of, and the intention is that the CPA permafrost glossary will also use this same representation for a machine readable list of vocabularies, and one of the things there is that you have identifiers for each term, so you can point to it. You can go to a kind of a stable landing page for it, and what that means is that you have ways of saying, well, here's my landform list that's established for a certain purpose, and here's my CPA glossary. And we can say in this language that this ice wedge polygon term, it's actually the same thing as this ice wedge polygon term. And that can make the integration of these metadata vocabularies something that you can be done automatically, and also makes it explicit for someone who's looking on the list. So just jumping back to here, there's another paper that came out recently about 10 simple rules for making vocabularies fair, getting back to the FAIR principles. So I've put them down here. So rule 1, determine the governance arrangement. So who's responsible for the vocabulary? I think in a lot of cases it's obvious, but making that explicit, including licenses to indicate that these vocabularies can be reused. Make sure that the vocabularies are complete, that there's no terms missing. Have some sort of traceability, so keep track of how they're changing over time, and have a way of allowing people to contribute to them. Having a unique ID for each term, that in many cases this resolves to a web address. So if someone wants the definition or wants more information about a term, they can just put it in a web browser and see that definition and get the full information. This machine readable, so the figures here, the top representation is what a person, the URL, that's the unique ID. They just land on a web page and they get the terms and the definition, and you can also have more information here. And then there's this machine readable representation that would be behind the scenes and kind of invisible, in the same way that the code for a web page, the HTML, is not something that a person sees. It's all presented in a nice human-friendly format, but it's something that can be ingested by some sort of machine or computer to make these things more discoverable if you're searching for this, or make it more easily to combine these different vocabularies. Then number 7, provide metadata to the vocabulary, register it, so that, again, this makes it more discoverable. So there's different repositories you can put these in, make it accessible to humans and machines, and then have a process for publishing revisions to the vocabulary. These steps are all a little bit opaque, but I think, as an example, the British Oceanographic Data Center has done a really good job of this, and so they coordinate different vocabularies for metadata for the oceanographic community. This is one that's used to describe oil spill quantity. And so there's a nice web page. There's a description of each of these terms. It's licensed, and you can't really see it off to the side, but then there's also machine readable representations of this. And so I think moving towards more formalized and more fair vocabularies within Permafrost will serve us well, both as a community exercise and also to make sure that everyone's on the same page about what are, in the case of disturbance, what are the scientifically relevant ways we categorize thermal disturbance to permafrost? Or in the case of landforms, what are, making sure that when we're describing a research site, we're all this provides a way for us to describe in the same way what it is actually that we're measuring and where we're measuring it. And so which terms should we prioritize here? So this was something that I kind of looked at early in the network, a number of different metadata attributes in different permafrost databases. So I think I looked at the Northwest Territories, the Yukon, PIN, GTNP, Permos, and NorPerm. So which metadata variables, I guess, are in each of these, and how, which is the x-axis, so along the x-axis, these are terms that are included in either 1 or 6 of those different data sets. And then how important are they? So if you just have a Google Scholar search for permafrost plus the term, how likely is, how many search hits do you get? So it's, maybe a vague hand-wavy measure of importance. And then you can divide this into sort of 4 categories. So you get things that are absolute necessities that I think we as a community should be thinking about, that are in all of the data sets and also are in a lot of journal articles, things like topography, ground temperature, aspect, slope angle, disturbance. These are things that I think should be priorities for standardizing amongst the different data centers for describing data. You get things that are in this top left quadrant that are priorities, so things that aren't really in a lot of the databases but show up quite a lot in the literature. So permafrost presence or absence, permafrost zone. In the bottom left, these are things that don't really show up in very many databases and don't really show up a lot in the literature either. So these might be things like RQD, things that are leftovers from the way that the data were collected. So I mentioned in the old geotechnical reports, there's information about what kind of drill was used or what kind of drill fluid was used. So these are things that have kind of become included in these metadata templates, but they might be kind of specialized or more even legacies, things that were collected but aren't really collected anymore. So finally, like getting to a model of data distribution within the network, as I said, there's data collected by the network that, because we're not a data repository, needs to be put somewhere where it's stable for a long term. So data publication or something like Nordic-ND, but then also to serve the needs of the network and to build these prototype systems, we're putting it on some server that's run by the network. And then using ERDAP, which is a tool for interoperable data distribution with a standard interface and different ways to access to serve the needs of different people. This is something that can feed in any number of things. So as I showed a few different web services that have already been built, provides a way for different themes to share, a platform for different themes to share data to facilitate the research. And then working with CCADI, who is I guess a PermafrostNet partner and its own organization, they're developing a federated search, so a way to have a single interface for searching data sets from different data sets and different databases. And so this is one way to feed into that. It's one of the standard interfaces that they plan to support. And then there are different ways that this model can feed into other organizations. So one is that, if there's another database or a data center that doesn't really want to run one of these ERDAP servers, that could the metadata could be translated using some of the tools I described, and then making sure that the attribution always goes back to the source. And so rather than PermafrostNet becoming a data center, which doesn't make sense because it's only around for a short period, it's focused on the distribution of data sets that exist using a certain interface. I'll just take a little breather here. So that's kind of the data interoperability, fair data piece. And now to conclude, I'm going to just talk about 3 tools that are either new or kind of revised to support simulation and data handling within the network. So the first is a tool, GlobSim, that's used to create time series data for specific locations from meteorological reanalyses. The second is something that can be used to build, run, and aggregate simulations on the Compute Canada infrastructure. And then lastly, a kind of handy tool for time series data to just make working with data and data logger exports and model outputs a little bit easier. So first off, GlobSim is a tool that was originally published by Bin Cao and others in 2019. It uses meteorological reanalyses, which are global climate models that have sort of best estimates of many different atmospheric parameters, air temperature, solar radiation, dating back to the 1980s, but they're all a little bit different. It's hard to integrate them, and they're on a grid rather than at a point, which is what we often need for running models or doing permafrost science. And what it does is downloads data from these reanalyses, scales it to a common time step, a common units, and interpolates it to a point location, so it can be used for model input or for just investigations at a site, and gives you the kinds of variables that you might be interested in: relative humidity, air temperature, solar radiation. And so through some through my work with the network, I've been working on some improvements to it to make it easier to use and just better suited to the kind of work we're doing. So faster download and data interpolation. We have downloaded for 3 reanalyses data from 1980 to 2021 for select regions. So if you're interested in using this, that's something that's available, and I'm happy to provide access to it. Ease of use improvements, bug fixes, and better scaling for things like shortwave, long-wave partitioning, or shortwave partitioning, and then shortwave and long-wave scaling with topography and elevation. This is something that's ongoing. And very soon, I'm hoping to introduce a pilot program to provide the output time series for people within the network. This tool can be a little bit temperamental to use and is quite technical. And if anyone is interested in being a part of this and has some research sites at which they'd like estimates of meteorological conditions dating back to 1980, let me know. The data archives are right now limited to kind of terrestrial Yukon, Northwest Territories, Nunavut, and then also in BC. So if you have sites there and you'd like to use this, let me know. And also, if you want to use it yourself on the PermafrostNet server, that's also a possibility. So the next thing that I'll describe is something that I'm collaborating with 3 HQP in theme 3. So Galina, Hannah, and Emily are kind of helping develop this and helping test it. So it's a toolkit to simplify running simulations on the Compute Canada supercomputing grid. So you can, so it also makes it easier to compare the outputs of different models. So there's right now it works with Geotop and Classic, and we're working on integrating a third model that's has the capacity to handle excess ice in permafrost. And some of the challenges in running many of these simulations together is even just building the input files that you need. And so there's kind of 3 steps here. So the first step is something that builds the job directories. Each directory will have, the meteorological inputs, for instance, the the soil parameters, and then it submits those jobs to a scheduler. So running on the Compute Canada infrastructure, it's a bit more complicated than running it on a desktop because it's a shared resource with hundreds of other people. And this tool abstracts a little bit of that so that you don't have to worry about some of the technical details. And then finally, the last step is collecting the results so that they can be compared. I see that I'm maybe starting to run a little low on time. Just go to my last slide here, which is a project that I've recently started to have a consistent way of handling time series, of dealing with ground temperature data in Python in this case, but because a lot of the CSV files that we see for ground temperature data are diverse and all kind of different, I've noticed certainly in my own workflow and in other people's workflow, it's very easy to just constantly be rewriting the same code same code to do data exploration for different outputs. So if you get different kinds of data loggers or different model outputs, if you have all these different files, they're all a little bit different. You just end up rewriting the same thing for data exploration. And so what this is, it includes a library of CSV readers, basically for different outputs, whether it's model outputs or data logger exports, and then generic plots for data exploration. So these aren't for data publication, but they make it easy to open either a data logger export or a model output and just explore it and see what's going on. It handles all of the variability of the different outputs, and the idea is that it'll be a common interface to handle 80% of the different kinds of use cases. So making trumpet curves, making these time series, and to save time in the data exploration phase so that you can focus more on generating the publication ready figures. In the future, sort of the intention is that this could be something that would have a web interface. So you could go to a website, upload your files, and then just visualize and explore them, rather than having to do any of the programming stuff yourself. But that's kind of a future step.
Thank you, Nick, for your presentation. We will now take questions. If you have questions, please write them in the chat or just unmute yourself and ask.
Charles, is it okay if I ask one?
Sure.
Okay. Yeah, thanks, Nick. Actually, I mean, being a modeler, I mean, these kind of last ones are the ones that were most catching my eye, just because I was kind of curious about how you guys were going to deal with this. And this teaspoon looks like it could be handy for some of the models, just because it's a simple way to look at how things are coming out. And it's actually your very last thing that I was the most interested in. What is this dash thing, and like what's the kind of idea? Is that the idea that it would kind of somehow run a container that like a user would just kind of upload their stuff into and produce plots, or how is that going to work?
So it's something I've only done a little bit of testing with. Dash is I think it markets itself as a scalable way of running it's scalable dashboards for Plotly, which is the kind of plotting library that's used for a lot of these web visualizations. And so I don't think it's containerized. It's something that you can run it so it deploys on multiple servers and scales well. I think as a first instance, it would be something where it really just looks like a website, and it would be something you could go upload the file and just generate these plots kind of on the fly. The challenge that I've found is when you start to get very large data sets, the way it handles that is it just takes a little bit of time, which is why I haven't really put too much time. I'm still trying to see if there's a way of handling those larger data sets. There's a few libraries that are used, but yeah, I haven't quite figured that out yet.
Okay. Yeah, because I think that sometimes people, like you said, people waste a lot of time on trying to just look at what's going on. And if you got kind of ready-made solutions, I think it can really help people. So yeah, okay. Thanks for that. Thanks for your talk.
Yeah, thanks, Joe. It certainly could also be something that gets put into a containerized environment, so you don't have to worry about any of the dependencies. But even that, I think, is a little bit technical. Ideally, it would be something where you didn't have to know about running Docker or Singularity to be able to just drag and drop a smaller file in and look at it.
Yeah, I think that's a good point, because for our model, we have a container, and it's very helpful because for our model, being that it's a compiled model, I mean, we have a bunch of libraries. It depends on these sorts of things that kind of make it complicated to run. And so, we provide a container, but then the container actually, like at one point, the underlying software updated it to a point where we have to now update the container recipe for that, particular one. So it's not a perfect solution. But in this case, because like you say, you're just kind of doing a more simple thing, then maybe it can be done without that, and maybe simpler. And actually a web interface. I mean, the nice thing is that that's obviously something that people are very familiar with. There's not a lot of counterintuitive, or not counterintuitive to use a web interface. So that's pretty cool. Okay, thanks.
Yeah, thank you. Well, the classic temperature outputs, they're fairly standardized. Am I correct in assuming that?
Well, yeah, they follow the same convention as like the coupled model intercomparison project. I mean, that's, like in the naming and all that sort of stuff. So within our community, we're very conventional. I'm not sure exactly how it interfaces with maybe the observations, but they are CF. So that's what you were basically saying. So it should be the same.
Yeah, cool. Well, I'll look at adding the classic model outputs as one of the readers into this as well, because I think it's probably wouldn't be too much work to implement that. And
actually, your plot there on the left of your color contour plot, I mean, that's what I would see when I plot our model.
Okay.
Depth, temperature through time, it would look very similar. And then your right time series plot, I mean, if I just chose I don't know, skin temperature or something like that, it would look like that. So, I mean, this sort of tool should be similar. And actually, the only difference is, of course, is that we typically produce NetCDF, but it's a very simple step to go from NetCDF to CSV. In fact, we have a little helper script that we use for doing that. If people don't want to deal with NetCDF directly, the only difference is that when you're on a grid, of course, NetCDF is a benefit. So
yeah. Cool. Thanks.
No problem. Thank you.
All right, thank you. We are at the end of our time here. Thanks, Nick, for the presentation. Thanks, everyone, for coming to the seminar, and keep an eye out for the next one. It will be announced in the newsletter, I believe.